We are talking about permutations. The next time we meet, we'll talk about combinations. So there's two different types. There's buttons in your calculator, there's buttons on Desmos that will help us solve these two to make it a little bit easier on you. So I'm going to kind of move into that now. And this should be at the top of your notes sheet. How many ways can a president, vice president, and secretary be elected if there's 5 people in the election? So for these, there's a couple, like the first way that I would do it is just listing out, like there's president, there's vice president, and then there's secretary. So I kind of leave my little blank spots open for that. Okay. And then your president is being elected first. So how many options are there to select that president? How many people can we choose from? And as we, obviously no one's shouting it out all at once, but if you're looking at the problem, there's 5 people.
5 people.
Thanks, Trevor. Yeah, 5 people. So you 5 to choose from. You pick one of them for president, but you had 5 choices. Now that one of them's picked for president, they can't be vice president as well. So now we have 4. And then 3 for the secretary. So here we're not going all the way down to 1 like we did in the last one. We just stopped. We're just worried about those 3 positions, the president, vice president, secretary. So then you just multiply those across. And there should be 60 ways. Okay. So this is the idea of a permutation. What's different about this is a permutation doesn't always go down to 1. So it'll stop. It cuts itself, it cuts short. So here we only had 3 positions, even though there was 5 people. We'll just go through a few more examples and kind of see. So permutations, I think you all have like a table on yours. All I say on the left side is order matters. Order matters. It matters if you're picked as president, like you better dang well be president. You're not going to settle for being the vice president or the secretary. The order matters of how you're being arranged. So next time we'll talk about combinations. That's going to be order does not matter, and then we'll kind of see the differences between the two and look at questions like that. Let's see. The formula for it. So I think I have formula for you. We use like the letters N and R. So it's like a NPR is what it kind of looks like, and that's I think what it looks like on Desmos too. I'll have to pull it up here in a little bit. N is your total, and then the R is like how many spots to fill. That's how I like to describe it, or how many you're picking. So how many spots to fill is what I write. And I'm gonna show the formula. We'll maybe do one example like that, and then I'll show you how to do it in your calculators. That helps make it go just a little bit faster, a little bit easier. So the formula for this is you have the N and the R, so the total goes on top. And then you do factorial. So it'd be N factorial divided by, and then in parentheses, N minus R. Close it, and then do factorial. Okay, so for the example above, there were 5 total people. So that would have been like 5 factorial, and we're picking 3 positions. So it'd be 5 minus 3 factorial. That was like the problem that's up above. Okay. And we'll do example 1 like it as well. Okay. So I'll just kind of pause a little bit. Let y'all catch up. Any questions so far? Y'all doing pretty good.
Do I need Desmos out or a calculator?
Desmos would help if you want to do like a split screen. It might be hard to do that. If you have your like a scientific calculator, those will work too.
Yeah, I can't find mine, so I'll just use Desmos.
Okay. Yep. That's perfect. I'm gonna try and find it. Yeah, it's right there. If you hit functions and then go to stats, that's where it'll be. So we'll use that here on the next one if I can find it. Okay. So it says there's 10 finalists in the figure skating competition. How many ways can gold, silver, and bronze be awarded? So again, like it's specific. The order matters. If you're getting first place, you're not going to settle for getting the bronze medal. So this one you have 10 total and you're picking 3. So we'd write it as 10 permutation 3. So we have 10 total, we're choosing 3. The number on the left should always be bigger than the number on the right. Okay. So as the formula goes, this would be 10 factorial divided by, and then in parentheses, 10 minus 3 factorial. And some of you are going to be able to jump right to doing this. 10 factorial over 7 factorial. I just subtracted the parentheses. Okay. And this looks just like what we did yesterday in some of those examples from the notes. On top would be 10 times 9 times 8 all the way down, but I'm going to stop it at 7 because then with the 7 on the bottom, they just cancel out. So it'd just be 10 times 9 times 8. I get 720. So there's 720 different ways. I'll show it in Desmos here now too. Okay. In Desmos, I believe you always need to type in the 10 first, like that first number. Same thing in your calculators. If you're using a graphing calculator, you hit the math button and go all the way over to PRB. And there should be, the second one down should be NPR. But again, you want to type in 10 first. Same thing in a scientific calculator. You want to type in 10. And then I think there's a PRB button that you can click. Okay, so always type it in that first number for like the first number. Then going to functions. NPR is right in the middle towards the bottom. And Desmos does it totally different. I was worried about that. So Desmos, you don't want to do 10 first. You'll do 10 and then comma 3. That's how it's going to look like in Desmos. If you're doing it in a calculator, you want to type in the 10 first. Okay. Or you can write it out like we did too. It's nothing too crazy. You could also think about this one just like the first example we did. You have gold, silver, and bronze. How many people can win gold? How many people have a chance to win gold? Well, 10. And then one person wins it. So then now there's 9 people left for silver and 8 for bronze. You could think of it that exact same way too. Okay? Let's try out another one. Okay. Newspaper has 9 reporters available to cover 4 different stories. How many ways can the reporters be assigned to cover the stories? So I'm going to show it I'm going to show it two different ways. I'm going to show it the way we did it, like the very first example with president, vice president, and secretary. So you have 9 reporters and there's 4 different stories. So here's one story. Maybe it's a murder story. The second story is about charity. The third story is about sports. And the fourth story is about COVID. Okay, so there's 4 stories. There's 9 reporters that have a choice or have an option of doing the first story, the murder story. One of them takes it, and now there's 8 left for a charity, 7 left for sports, and 6 left for the COVID story. And then you just multiply those going across.
I get 3,024.
Yes.
All right, sweet. I'll just make sure.
Perfect. Yeah, so this is one way to think about it if you're like kind of not going to deal with formulas. If you are going to do the NPR formula, this would be 9P4. So we could type it in Desmos right over here. No. So I'll go back to how we get to that NPR. So it functions, it's in stats, and then right towards the bottom in the middle, there's NPR. We're going to do 9, 4. Okay. How it looks in the formula would be 9 factorial over 9 minus 4 factorial, like that. Okay. If you are kind of taking the shortcut or whatever, I at least want to see this. If you're typing that in, just because then I know what you've typed in. If you end up getting the wrong answer, and later on, like I said, we're gonna be doing ones with P's, ones with C's. So if I don't know what you typed in, then I won't be able to kind of help you out. So as long as you show this part, the 9P4, and then write the answer, I'm totally okay with that. That's enough for me. Okay. All right. Now we get into some fun stuff. It says, how many ways can the letters of the word math be arranged? So we're going to just rearrange it. It doesn't matter if they make sense or not. But there are, looking at my notes here. So just writing it out, MATH is one way. And then I could switch around the T and the H. So I could just do MAHT, like that. Then I could do MTAH. I could do MTHA. So I'm only starting with ones that start with M, and then I could do MH. And I could do like MHAT, MHTA. Holy cow. Okay, so that's 6 ways. But that's 6 ways that all start with an M.
I think I have the answer already.
What do you think, Trevor?
24.
How'd you get that?
4P4 and Desmos.
Oh. Now you're making me think.
Because there's 4 letters and then 4 different ways you could there's 4 different slots. You can switch it up.
Yeah.
I did the same thing.
You did the same thing, and I think that actually works. That works out pretty well. In this case. In the next ones, it's not. And I'll kind of talk about why. So, once we get to that next one, I'll talk about why, but it does work here if you do 4P4, just like you said. And if we think about it, too, how, we're listing it out, these are 6 ways to start with just an M. If I started with the A, I'm going to have 6 more ways. If I start with the T, 6 more ways. H, 6 more ways. In this case, 4P4, it works. So there's 24 different ways to rearrange it. That's awesome. That's super cool that y'all like did that and it worked out. But it's not going to work out in the next one. Okay.
Yeah, is it because there's repeating letters?
Exactly, yeah.
So
Home.
it's 5P2, right? I think that's how it would work. Because there's only 2 other letters.
Trevor, do you just want to teach the class?
Yeah, I think you should.
I think he's ready.
What about number 5?
All right.
Yeah, I mean, honestly, Trevor, you got it right there for example 4, but I don't think that's gonna work for example 5. So unless you're one step ahead of me, but yeah, for the word deer, like in John Deere, there's 3 repeating letters. So if I wrote it like this, and I'm gonna purposefully do different colors for those E's. And then I switch around those E's, nothing's changed. So that's why Trevor's like, there's repeating letters, so you just do 5P2, because there's really only 2 letters that you're rearranging. Which is true. I'm gonna show a different way that'll work every single time. And what I do is I put the total number of letters on top. So there's 5 total letters, and I do 5 factorial. And then we do the repeated letters on bottom. Which here there's 3 repeated E's. So I maybe put a little E there. I like putting parentheses around it when I'm dividing. I might not have done that before, but and then this, what we have written, is the same as 5P2. Okay, so for that word Mississippi, we're gonna have to do a little bit more than just a permutation. What did you end up getting, 20 on this one? Yeah. Okay. So we do the total number of letters on top, and then we do all the repeated letters on bottom. And I like to show like what each letter is, or whatever, like what the repeated letters are. So total letters on top, if I count them out for Mississippi, 11. And then the repeated ones on bottom. Well, there's 4 I's. So I have to do 4 factorial for the I. There are 4 S's. And then there are 2 P's. So what this is doing is, like, for those 4 I's, we could move those I's around. Just the I's. If I only move the I's, we can move those around 24 different ways. That's what this 4 factorial represents. So I can move those I's around 24 different ways, and I need to get rid of all 24 of those ways because I only want one of them. That's why we're dividing it out. That's why we divided the 3 factorial, because there's 6 different ways to rearrange those E's in deer above. So for this one, I don't think you're able to do it just a regular old permutation. I think you have to do the factorial. When I do it, when I type this in Desmos, I hit divide first, because then I get that fraction bar. You should be okay if you didn't. And then if you just go to ABC to get that factorial. If you are using a calculator, just make sure after you hit divide, you're using these parentheses. And then I get 34,650 ways. Okay. So that's like the two types of, I'll call them permutations. I don't like calling these rearrangements permutations, but the order still matters, the way that the letters are in, because that's what makes the words, like that's what makes them different. So the order still matters with those rearrangements, and then same with those examples above. That order matters on if you're getting gold, silver, or bronze.